Hey guys, how's it going? In this video, I'm going to walk through this Leetcode 1135, connecting cities with minimum cost. So this problem was asked by mostly Amazon, 22 times in the past 6 months. So it was quite popular. And so there are n cities labeled from 1 to n, and we are given the integer n and array connections where the connection of I is equal to a list. And so we have the CDXI, CDYI, and also the cost connect the X to Y. And we need to return the minimum cost to connect all the n cities such that there is at least one path between each pairs of cities. If it is impossible to connect all the cities, we have to return -1. The cost is the sum of all the connections costs used. So let's look at an example in here. We have 3 cities, and one city 1 and city 2. The connection between 2, we have to pay cost of 5, and for 1 and 3, we have to pay a cost of 6. For 2 and 3, we have to pay a cost of 1. So the cheapest way to connect all the cities will be connecting 1 and 2, and then we pay a cost of 5, and then connect 2 and 3, we pay a cost of 1. So in total, we just only have to pay cost of 6 instead of connecting 1 and 3, which you have to pay 6 already. So this is the first example, and second example is we have cities 1, 2, and 3, 4, and there's no connections between 1 and 3, and no connections between 2 and 4. In this case, there's no way to connect all the cities, all the 4 cities, and we can return the cost of -1, meaning there's no way to connect all the cities. We will solve this problem using a graph and then use a priority queue. So the weight of the queue being the cost, because we want to find the minimum cost to connect all the cities for each of the steps. So let me walk through my notes with you. So consider this example. This is actually one of the test cases. So we have city 1, 2, 3, and 4. And for city 2, there's only one connection, and that connects to city 1. And 3 and 4, 1, 3, and 4, they interconnected. So the solution is 6. So basically, that's the minimum cost. So basically, we connect 1 and 2, and because again, so city 2 has only one connection, so we have no choice. And then we connect, and then we spend cost of 2 and spend cost of 3, and this connection, that's the most expensive one, and we don't consider it in our solution. So for each of the connection, right? For example, when we have a choice, for this one, 2 and 4, and the minimum will be 2. And when we have a choice, two choices, right? 3 and 4. And when we are at the node of city of 4, we have two choices, 3 and 4, and then we will consider minimum cost, the choice that has the minimum cost, which is 3 in this case. So again, we will use a priority queue to solve this problem, and the priority or the weight being the costs to build connections. First step is to build a graph, right? And the graph, I built it using the dictionary, the key being the city, and the value being a list or an array. So the first element is a cost to build connection, and the next element is the what city that we are connecting to, and then we can build multiple connections for the single city. That's why I put a dot 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 in here. So for example, for this city, right, city of 4, and we pay a cost of 4 to build connection with city of 3, and then that's the first element. And the second element would be cost of 3 to build connection with city of 1. So the first step is build graph. Second step is solve the problem using a priority queue. And So the first one, so the structure of the priority queue is um, the first element is same as that. It's a cost, and also second element is the city that we are standing at. For this particular example, I started with the last city, which is 4, and then right now I don't need to pay anything because I haven't built any connection, so it's cost of 0. So it's corresponding to cost and also city. And then I look at the graph for a city of 4. I have two choices, right? Cost of 4 to build connection with city of 3, or cost of 3 and build connection with city of 1. Okay, so I push them in a queue, and then use a heap to push out, to pop off the connection that has the lowest cost, which in this case is 3 and 1. Pay a cost of 3 and build connection with 1. Okay, and then now the current city is 1. So I look at the graph at the city of 1, where I have two choices again. So either I pay cost of 2, build connection 3 with 3, or I pay a cost of 3 and build connection 4. Okay, so I push it to the queue. So the priority queue or mean heap push out or pop it off the connection that has the lowest cost, which is 3, pay a cost 3, and build connection with 1, city of 1. Oh, sorry, it should be here. Pay a cost of 1 and build connection with city of 2. Sorry about that. This is the one that we had already. And then we look at the graph at the city of 2, where we have only one choice. We pay a cost of 1, build connection to 1. And then we use a mean heap to pop off the one that has a minimum cost. In this case, is this one over here. Pay a cost of 2, build a connection with 3 with 1, city of 1. So that's a walkthrough of this algorithm. And again, the first step is to build a graph. Second is use a priority queue or use a mean heap. Let's see the implementation. So first step, I have again build. This is how we can build the graph. We have a neighbor, which is a default dictionary. So the default element is the list. So for all the cities and city 1 and city 2 and the cost in the connections, and the key being either city 1 and city 2, and then the value is a list. Again, the first element is cost, second element is the city that we're building connection to. Let me show you what it looks like. So city 1, we have to pay cost of 5. So this is the first example. For city 1, we have to pay cost of 5 to build connection with 2, city of 2, and secondly, we have to pay cost of 6 to build a connection between city of 1 and city of 3. Okay, so that's what it looks like. This neighbor dictionary, which is a graph. And then this is the total cost that we keep track of. And here is the priority queue, where we will use the mean heap to push out or pop it off the connection where that gives us the minimum cost. And we have the visit set to keep track of what city we have already built connection with, so we don't repeat the work. So while there's something in the priority queue, let me zoom in a little bit. While there's something in the priority queue, and then we use a mean heap to pop off the one that has the connection that has the lowest cost. So the current cost and the current city is what is being popped off, and the starting point, as you can see, is we are at the last city. We can choose whichever we want. We can choose the first city, second city, doesn't really matter. I choose the last city. And since we have not yet built any connection, that's why the current cost is 0 at the beginning. So we pop it off, and now the current city is being visited, and we push it to the visited set. If the city has been visited, we don't do the rest. Okay, and then we added the cost to the total cost, and this is a terminal condition where if all the city we have already visited, well, we don't have to do the rest. We just automatically return the total cost, and then we look at the graph for that city, and we pop off all the possible connection for that city, and then we push them to the priority queue, and then at the end, it comes back to the top of the while loop, and then pop off the connection that has the minimum cost. At the end, if this statement is not executed, that means there's no way to build all the connections. We return a -1. Okay, submit that. Looks okay. Faster than 50% of the solutions. So for time complexity, as you can see, when we build the graph, this is gonna be taking a big O of n, n being the number of connections. And when we use a priority queue or min heap, and this takes when we pop it off, and also the heap pop and also the heap push, both of them takes a big O of n log n time. Okay, and we do that for n times, n being the number of connections. So this is my solution. I hope this is helpful. And actually, there is another solution where we can use a sorting and union find. I'm gonna solve that in another future videos. Thank you so much for watching, and I will see you in the next video. If this is helpful, please like and subscribe. Thank you.